Question number 55 from NEST 2018 on trigonometry. Let x0 be positive. For every natural number n, define Sn as sine of pi x0 raised to n upon 1 plus x0 raised to 2n, and Cn as cos of pi into x0 raised to n upon 1 plus x0 raised to 2n. Then for all n, Sn squared plus Cn squared is equal to 1. Sn is greater than or equal to Sn plus 1. Cn is greater than or equal to Cn plus 1. Sn upon Cn is greater than or equal to Sn plus 1 upon Cn plus 1. This is a multiple select question, so we have to investigate the validity of each and every option. Let us start with option A. Okay, let us start with option A, which says Sn squared plus Cn squared is equal to 1. Observe that the angle here and the angle here, both these angles are same for given n. Okay, so and here they are saying for all n. Okay, now we know for all angles theta, in the set of real numbers, sine squared theta plus cos squared theta is 1. So A is correct. Okay, A is correct. Now if you look at options B, C and D, okay, they are pretty much similar in a way that they basically are asking us whether that sine function is decreasing in this case, cos function is decreasing, and tan function, right, in the option D. So before we go deeper into these options, I would like you to take a note of the following fact. Okay, look, suppose I select x0 as 1. Okay, suppose I select x0 as 1, then what will be the expression pi x0 raised to n upon 1 plus x0 raised to 2n? This expression will be pi by 2. Okay, this expression will be pi by 2, and it is independent of n basically, right? This will be independent of n, correct? This will be independent of n. So Sn will be sine pi by 2, Sn plus 1 will also be sine pi by 2, and so on. And how about the cos term? For cos term, we will have 0 because it's cos pi by 2, right? So the trivial case of x0 equal to 1 is not going to be of any use, much use, as far as deciding options B, C and D is concerned, because all of them are slack inequalities. Basically, they just don't say less than or greater than, less than or equal to, or greater than or equal to. Okay. The case D here, where Cn is 0 if x0 is equal to pi by 2, is of some concern to us, but let's keep that aside for time being, and let's focus on other values of x0. Okay, now here is the thing. Observe that the expression x0 raised to n upon 1 plus x0 raised to 2n can be written as follows. Okay, let us divide the numerator by x0 raised to n, so the denominator will also get divided by the same thing. Okay, plus x0 raised to n. Right, now look, because x0 is positive, the angle is going to be positive, and if you divide it by pi, then it will still give me a positive number. So no matter what value of x0 we are going to choose, positive real numbers, right, this will always be greater than 0. Okay, that's first thing that we note. Now I want you to consider the following two facts. Okay, I want you to consider the following two facts. If x0 is greater than 1, okay, if x0 is greater than 1, then x0 will be smaller than x0 raised to 2, it will be smaller than x0 raised to 3, it will be smaller than x0 raised to 4, and so on, right? And this will basically give us an increasing sequence, right? And if I consider x0 less than 1, okay, then x0 will be greater than x0 squared, it will be greater than x0 cubed, it will be greater than x0 raised to 4, and so on. Okay, and so on. But it would be interesting to see that when it comes to the reciprocals, Okay, when it comes to the reciprocals, let's say 1 upon x naught, then 1 upon x naught squared, and so on, then the sense of inequality reverses, correct? Then the sense of inequality reverses, and here also the same thing happens. Okay, 1 upon x naught is smaller than 1 upon x naught squared, smaller than 1 upon x naught cubed. Okay, now why did I tell you this thing? Look, here what we are taking is, we are taking n, and then we are taking 1 upon x naught raised to n. Okay, then we are taking 1 upon x naught raised to n. So if I now decide to consider the expression x naught raised to n plus 1 upon x naught raised to n, okay, I know I'm going to get the same behavior whether I take x naught to be greater than 1 or if I take x naught less than 1. Correct? It doesn't really matter because we have x naught raised to n, and we also have its reciprocal raised to n. Okay, so let us take into consideration x naught greater than 1. Okay, x naught greater than 1, and let's see whether we get larger and larger values if we have if we go on taking the larger and larger powers of this. Okay, well, remember we are supposed to add both the number raised to that a power plus its reciprocal raised to the same power. Okay, and we need to decide now whether we get an increasing sequence or a decreasing sequence. Okay, we have to decide whether we will get an increasing sequence or a decreasing sequence. As n tends to infinity, because that will help us a lot in deciding this. Okay, whether it is greater than or equal to that stuff, because look, this positive, all the angles here are positive. Okay, and we will soon find out that the limit of these angles is pi by 2. Okay, so all the angles are acute angles between 0 and pi by 2. Okay, but we need to systematically reach there. Okay, okay, now look, x naught is already greater than 1, that's what we have said, and let us we can choose a representative number. Okay, we can choose a representative number for that. So let us consider x naught as 2. Okay, let us consider x naught as 2, and then what will we get? We will get 2 raised to n plus 1 upon 2 raised to n. Okay, 2 raised to n plus 1 upon 2 raised to n. Okay, and we have to now decide whether 2 raised to n plus 1 plus 1 upon 2 raised to n plus 1 is greater or less than this. Okay, okay, greater than or less than that. So how to go about doing it? Okay, how to go about doing that? Look, this number, whatever number we are going to take, okay, that will always be greater than 2 because of 2 raised to n. Okay, because of 2 raised to n. And if I consider a function of the kind 2 raised to x plus 1 upon 2 raised to x, and if I find its derivative, let's see what we get. We will get 2 raised to x ln 2. Okay, we will get 2 raised to x ln 2 plus, now this is 2 raised to negative x, so that would be, or 1 upon 2 raised to x, so that will be 1 upon 2 raised to x. Okay, 1 upon 2 raised to x into ln 2. Now did you observe that ln 2, whose approximate value is 0.693, okay, every term here is positive, every term here is positive. What does it tell you? It basically tells you that the derivative of this function 2 raised to x plus 1 upon 2 raised to x is positive. Okay, it is positive. Oh wait, oh okay, I think I have made a mistake here. This is not ln2, this should be ln1 upon 2. Okay, ln1 upon 2. Okay, ln1 upon 2, yeah, okay, because it was 1 upon 2 raised to x. Okay, but let's see whether our argument still holds. Okay, let's see whether our argument still holds. What we can do is we can take ln2 common. We can take ln2 common, and then inside it will be 2 raised to x minus 1 upon 2 raised to x. Okay, 2 raised to x minus 1 upon 2 raised to x. So look, now how did that negative sign come here? We know that ln 1 upon 2 is negative ln 2. Right, now here is the thing. Here is the thing. If we choose any number greater than 1, then 2 raised to x will be greater than 1 upon 2 raised to x. Well, there is an issue with x equal to 1, but I will tell you that it is actually an extreme value when x is equal to 1. I will also show you that later on Desmos. Okay? But as of now, our job is done. For all x greater than 1, and in fact, see, x is actually playing the role of n here. X is actually playing the role of n here, and our natural numbers, they start from like 1 to 3, right? So that's fine. So 2 raised to x is greater than 1 upon 2 raised to x, which confirms that derivative is positive. Okay, which confirms that derivative is positive, which means it is an increasing function. It is an increasing function. What does it tell you? It basically tells you that if I take this inequality, because it is an increasing function, we will get this. Okay, we will get this. Now, because we had generalized it, we can now talk about this function. We can now talk about this function. This function now being, well, we have already ensured that the values are positive. This function is increasing. But we actually don't have that function, right? What do we have? We have its reciprocal. Okay, we have its reciprocal here. Okay, we have its reciprocal. Now, if its reciprocal is present, okay, if its reciprocal is present, if a sequence of positive numbers is increasing, the sequence of reciprocals of those positive numbers is decreasing. So what conclusion have we now drawn? This is decreasing, right? And because it is decreasing, so is pi x naught raised to n upon 1 plus x naught raised to 2n is decreasing. So is this. Okay, which means the angles are getting smaller and smaller. Now look, because the sequence is decreasing, okay, the sequence is decreasing, let us try to find out the limit as n tends to infinity of this. Okay, pi x naught raised to n upon 1 plus x naught raised to 2n. Okay, n tends to infinity, so we can write it as limit n tends to infinity. Pi has no role to play, so let's write it here. Let's isolate it. Again, let's divide the numerator and the denominator by x naught raised to n. So it will be x naught raised to negative 1 plus x naught raised to n. Okay, and we know that this limit is going to be 0, because if n tends to infinity, right, if n tends to infinity, doesn't matter whether x naught is greater than 1 or less than 1, one of these numbers will tend to 0 and the other will tend to infinity, so this will be 0. Okay, this will be 0, which means the angles start from pi by 2 if you want to take x naught as 1, and then the angles eventually decrease to 0. Angles are decreasing to 0. Okay, so right, angles are eventually decreasing to 0. So what can we say? As angles are positive and decreasing, okay, as angles are positive and decreasing, what will happen to the signs? Sin x, okay, sines of the angles will decrease, because sine increases from 0 to pi by 2. So if you are approaching 0, then of course sines of angles will decrease. Yeah. Okay, this will hold, and for cos it will be opposite. Okay, sine and tan, they're in the decreasing, okay, because the angles are approaching 0. But for cos, if the angles are approaching 0, then cos 0's limit is 1. So we must say Cn is less than or equal to Cn plus 1. Okay, now let's come to the options. Let's come to the options. We have successfully concluded that B is right. D is right, but not C, right? C is not right. Okay, C is not right because Cn is greater than or equal to Cn plus 1, because the angles are positive and decreasing as n increases. Okay, now there is still that issue about tan. Okay, there is still that issue about tan when x naught is equal to 1, but well, I think we have to kind of reject it or ignore it, so to speak. We have to ignore it. Maybe they should have specified let x naught be positive and not equal to 1, because otherwise the validity of option D is questionable. Well, now I have included D because in the official solution they say that D is right. Okay, they say that D is right, so I have to assume that rather we have to assume that the case of cos pi by 2 doesn't exist. Case of pi by 2 doesn't exist. Well, actually it very well does exist if we consider just the things given in the problem. Okay, all right, so it was a pretty tricky question considering the fact that we had both sine cos, that means trigonometry part, and also the sequences and series part. Now we can go to Desmos and see the behavior of this x naught upon plus x naught raised to 2n function. Okay, yeah, so this is the PDF that I showed you. Okay, this is question 55 from that, and that's saying that D is also right. Okay, D is also right. Okay, so this is our grapher. We would like to choose first A. Okay, first type the function. So a raised to x upon 1 plus a raised to 2x. So here x is now playing the role of n. Okay, and as expected, when a is 1, then it is horizontal line. Okay, now first let's take the values which are greater than 1. Greater than 1. What do you see happening? You see that the function starts decreasing. Okay, the function starts decreasing. Let us paste it there. Okay, the graph of the function immediately starts decreasing. Okay, immediately starts decreasing. And is that what we concluded there? Okay, yes, this is what we concluded. Okay, so let me put that here. Okay, let me put that here. It doesn't matter because pi is a positive constant, so I hope you people will understand that pi has no role to play except for the scaling version, scaling the graphs, right? Now let us come to the next part. Let's make a less than 1, but keep it positive. Okay, and even there you find that it maintains the same behavior, right? Even when a is less than 1 but positive, it still maintains the same behavior, which confirms that it is decreasing. Okay, so the angles are decreasing, the angles are approaching 0, so we can draw the conclusions from that, right? And all angles are positive. Okay, so if you want, I can also give you the table at the end. Okay, as we go from pi by 2 to 0, sine decreases from 1 to 0, and cos increases, cosine increases from 0 to 1, and we have to say that now tangent decreases from infinity to 0, and that's the reason why we got those answers here, Sn greater than or equal to Sn plus 1 and tan. Okay, okay, but for cos we didn't get that, right? For cos we didn't get that. All right, so that was pretty much about NEST 2018 question 55.